Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 3, Lesson 9. Let's get started. All right, our first job is to determine whether the following numbers are in scientific notation or not. And the main thing that you're going to look for first is that your initial number is written with a single number. So anywhere from 1 to 10, greater than or equal to 1, but less than 10. And that means that we're going to have one decimal place. So you can see here on the first one we have a 1 and then the decimal. So we have a 1 and then the decimal. And then the trailing decimals, those can be anything. And it doesn't matter. Times, this is good, times 10 to some power. So this is a yes. Exercise 1 is a yes. 1.908 times 10 to the 17th. Exercise 2, you can see our leading number is not 1 or greater. And so this one is no good. The times is good, the times 10, and then an exponent. This is all good. But we need that first number before the decimal to be a 1 through 9. So this one's no. Exercise 3, 7.99, that's all good. Times 10 to the 32nd, yes. Exercise 4, we do have a 4 as our leading number, and it is in the ones place, so this is good. Times 10 to the 7th, well, we don't have 10 times. So that plus makes it no good. This is a no. Has to be multiplied. Two problems here. This should be less than 10 and 1 or greater. So that's no good. And then that has to be 10 as the base. The base must be a 10. So this one is also a no. And then we have 8 times 10 to the negative 11th. That's good. Remember, 8 is just like 8.0. We just don't put the decimal. But it is there. So this is a single digit, and then times 10 to the negative 11th. That one is a yes. So that's scientific notation. And let's calculate with it. So for this one, we're going to determine the sum. So we're going to add the debts of the 3 most populous states. So here are the states, and let's see, the 3 most populous states would be California and New York and Texas. So we're going to take the debt of those 3 and we're going to add them together. So first we need scientific notation. So we're going to write 407 billion in scientific notation. So let's do that first. I'm just going to write it down here and make sure that we can all change this into scientific notation. So here's the standard notation, and then in order to change it, I need my decimal to be here, right behind the 4. So I need to move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So this is going to be 4.07 times 10 to the 11th. 4.07 times 10 to the 11th. And we'll do the same with New York, and that means I'm going to move the same number of decimal places because they have the same digits here. And so that means I'm going to have 10 to the 11th, so this is 3.37. 3.37 times 10 to the 11th. And for Texas will be 2.76 times 10 to the 11th, the same number of digits, so it'll be our same exponent. Okay, and then we need to add all of those together, and since our base and exponent are exactly the same on all 3, I can go ahead and add my digits over here. So when I add these 3 together, I get 10.2 times 10 to the 11th. 10.2 times 10 to the 11th, and then we're not in scientific notation, notice, because my decimal is not in the right spot, so I need to move this 1 over, so this now becomes 1.02 times 10 to the 12th, since I moved one more over. So the total debt for those three most populous states is 1.02 times 10 to the 12th. Okay, and the important thing is that all of these powers have to be the same base, same exponent. All right, so let's try part B. What's the sum of the debt for the three least populous? So the three least populous would be these three. So those are the debts I'm going to use. And if I move this 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 4.0 times 10 to the 9th. And since they're all the same number of digits, they're all going to be to the 9th power. So also a 4.0 times 10 to the 9th for Vermont, and 2.0 times 10 to the 9th for Wyoming. And since I have all the same powers, I can just add. So this is 4, and 4 is 8, and 2 is 10. So this is 10 times 10 to the 9th. But I don't have it in scientific notation because now my decimal's here. I need to move it one more place, and this becomes 1.0 times 10 to the 10th. That should be a 10. 1.0 times 10 to the 10th. Okay, let's do part C. How much larger is the combined debt of the three most populous states than the three least populous states? So this is where we're going back to our last lesson, and we're going to go back and I'm going to grab our answers from the first two and put them in here. Okay, so this is the most here. This is the most 1.02 times 10 to the 12th minus the sum of the least, which I put over here, 1.0 times 10 to the 10th. Now remember, in order to add or subtract, I need the powers to be the same. Well, right now they're not. So I'm going to change this up a little. Our most expression, this one, I'm going to change this so that it has a power of 10. So I'm going to say 1.02. I'm going to make this 1.02 times 10 to the second power. Plus, I'm going to also say that this is multiplied by the 10 to the 10th, which is left. So multiplying that by 10 to the 10th power. And then notice, if I add these to the 2 and the 10, I get my 12, which I originally had. So I'm breaking that apart, and so that I can see a 10 to the second over here. All right, and then I'm going to say, well, I know that 102 or 1.02 times 10 to the second power means I can move this decimal two places, and that becomes 102. So now I have 102 times 10 to the 10th minus, and this is all in parentheses, minus 1.0 times 10 to the 10th. And now, since my powers are the same, I can actually do the subtraction. 102 minus 1 would be 101. So now I have 101 times 10 to the 10th. And I don't have scientific notation again. Now it's here, so I need to move it 2 places over. So this becomes 1.01 times 10 to those 2 places that I moved to the left make it 12. So 1.01 times 10 to the 12th will be how much larger the 3 most populous states are than the 3 smallest. Okay, let's use those figures again, and this time we're going to use the sum of the population. So we're taking the population this time of the 3 most popular states and populous states. So these 3, And let's see, I'm going to move 3, 6, 7 decimal places. So this is going to be a 3.8 times 10 to the 7th power. For California, then I'm going to have a 1.9 times 10 to the 7th. And finally a 2.6 times 10 to the 7th. And now that I have them all to the 7th power, I can add up, and I get 18.92. That doesn't seem right. Let me check my math here again. I'm sorry, that's 8.3 actually when I add those up. 8.3 times 10 to the 7th. So 8.3 times 10 to the 7th is the sum of the population. So 8.3 times 10 to the 7th power. So I'm going to keep that over there for a second. And let me give myself some room. And let's see, I've got, now I want the 3 least populous states. So I'm going to have to move 5 decimal places to get 6.9 times 10 to the 5th. For North Dakota, 6.26 times 10 to the 5th. That's Vermont. And 5.76 times 10 to the 5th for Wyoming. And now when I add those, this is where I get the 18.92 times 10 to the 5th. And remember, I can add those because my powers are all the same. And then I need to move 1 decimal place over to get 1.892. So I'm going to put that over here, 1.892 times 10 to the 5 plus 1, because I moved 1 place. So this is 10 to the 6th power. Okay, so there's our the sum of the 3 least populous states. And then I want about how many times greater the total population of California, New York, and Texas are compared to the 3 smallest. So since it says how many, I need how many times greater, this times means I'm going to compare them with a ratio. So I want the biggest on top, so I'm going to take the 8.3 times 10 to the 7th over 1.892 times 10 to the 6th. And right now I can't do anything because the powers aren't the same. So I'm going to make sure that I have those written in terms of 10 to the 6th so that I can actually do the division. And actually when we're dividing, we don't need to worry about that, so I can just go ahead and do the division. 8.3 divided by 1.892 is approximately 4.39. So approximately 4.39 times, 7 minus 6. Since that's division, I subtract, so times 10 to the 7 minus 6 is just times 10. And that means that to get my answer, I'll just move this decimal 1 place back, and I get 43.9 times greater, the population of the greatest populous states versus the least 3. Okay. And finally, all planets revolve around the sun in elliptical orbits. Uranus' furthest distance from the sun is approximately 3.04 times 10 to the 9th. And its closest distance is 2.749 times 10 to the 9th. Using this information, what is the average distance of Uranus from the sun? Well, since I want average, I'm going to add these 2 together. So I'm going to have 2.749 times 10 to the 9th. And I'm going to add that to 3.004 times 10 to the 9th. And so the first thing I'll do is add these together. And when I do that, I get 5.753 times 10 to the 9th. That gives me my 2 distances added together. And in order to get the average, I have to divide by those two distances, so dividing by 2. And when I divide by 2, I get 5.753 divided by 2 is 2.8765 times 10 to the 9th. So that is the average distance of Uranus from the Sun. Okay, that is lesson 9. I hope that helps. See you again next time.